Today I'm going to tell you about schema-based instruction, an evidence-based math intervention. In order to understand what schema-based instruction means, we must first understand what schema means in the context of this intervention. A schema is a way to organize or pattern information within a structured framework of known and unknown information. The main focus of SBI, or schema-based instruction, is to teach word problem solving using identification of a word problem schema, representation diagrams or equations to represent the schema, and solving the problem. Scaffolding of learning is provided throughout the intervention. Here we see a series of schema. You can pause the video and take a minute to read what each one is and example problems. With each schema, you can put a number in any of the boxes. So for a change problem, we could know the start and the end, and we have to find the change, or we can know the start and the change, and we need to find the end. With a compare situation, we can know the bigger number and the difference and find the smaller one, or we can know the smaller and the difference and find the bigger one, etc., etc. No matter the schema, and no matter the math that you are teaching, the first step is always explicit instruction in the schema. And that includes concept and skill development in what the schema is and how to draw it, why the schema is used, when the schema is used, and how the schema is used and filled in. It is vital, it is extremely important that we teach this explicitly and that students understand what, why, when, and how for the schema before we proceed. Once we teach this, then we can move on to the problem solution phase. The next step is explicit instruction in the problem solution phase, and for this we need to know FOPS, F-O-P-S. FOPS means find the problem type, organize information in the schematic diagram, plan to solve, and solve. In order to accurately find the problem type and organize the information, students must know the schema, which is why it is so important that you teach them the schema before you move on to this step. The third step is that we fade the use of schematics over time because our goal is for students to be able to complete word problems without schematics. This is scaffolding. This is not ripping it away immediately. You slowly fade the use of the schematics. Some students will always need the schematics or some form of them. So let's practice a problem. Laura needs 56 paper plates for a birthday party. She already has 27 blue plates and 16 red plates. How many more plates should she buy? So remember FOPS, the find, organize, plan, and solve. So to find the problem, I need to ask myself some questions. What's the question asking? What information is given to us? What do I need to find? And which schema do I use? So what's the question asking? She needs 56 paper plates. She has 27 and 16 red. How many more should she buy? What information is given to us? That she needs 56 and that she has 27 blue and 16 red. What do I need to find? How many more plates does she need and how many plates does she have? Here is a selection of schema that might be able to help us in solving this problem. Let's look at our two questions. How many more plates does she need and how many plates does she have? Well, how many plates does she need? I know that I have a number, which is the start. I have how many she needs at the end, right? The total number. So that's the end. It's the change that's missing. So that's a change situation. And for the second one, which is how many does she have? I know that I have a first number and a second number, and I need a total number, which means that it's a grouping situation. Now I've explicitly taught my students what these mean, how to find them, how to organize them. So they know how to do this stuff. Obviously, for the problem solution phase, I'm going to model it for them, make sure that they can do it before we proceed with guided and independent practice. So how many more plates does she need is a change, and how many plates does she have is a group. So find is done. Now I need to organize. But before I can get to that, I need to ask myself, which question should I answer first? In order to answer number one, how many does she need, I need to know number two, how many does she have? So I'm going to answer that one first. How many plates does she have? Well, she already has 27 blue and 16 red plates. Now, does the color matter? the end of the question does not ask us about color, so we do not have to worry about the color. So I'm going to put into my grouping situation 27 and 16. So now I found this type of problem and I've organized the problem in the schema. So now I'm going to plan to solve, and I know that a grouping situation requires me to add in this case. So I've planned 27 plus 16, and I'm going to solve. 27 plus 16 is 43. I'm going to move that to the schema. So how many plates does she need? Well, what information do I have? I know that she has 43 plates because we found that in the last problem. What information do I need? How many plates does she need to buy? It's a change situation. I also know that she needs to end up with 56 plates. So I found my type of problem, which is a change, and I'm going to start with 43. I'm going to end with 56, and I don't know the change that occurred, which is the middle number there. So now I've organized. Now I need to plan and solve. So I've done find and organize. Now plan. How do I get from 43 to 56? Well, I know that to get from a big number to a small number and find what's in the middle, I can subtract. Or I can add 1 by 1 by 1, but that might take a long time with this. So I'm going to subtract 56 minus 43. That's my plan. And now I'm going to solve the problem. 56 minus 43 is 13. So Lauren needs to buy 13 plates. So the evidence of impact on the population, there's tons of research on SBI, which we're going to look at on the next slide. The effect sizes on students with LD and or students with mathematical difficulties are reported. Often these students are mixed in studies. One study listed a P&D, a percent of non-overlapping data, of 92.73%, which is considered highly effective. Other studies listed effect sizes using Hedges G, which ranged from 0.44 to 1.87, which are moderately effective to highly effective. These studies all involved third graders and 6th through 8th graders. One study was third graders, others were 6th through 8th graders. One study listed an effect size for all grades, which was 1.77, and that had learning disabled students mixed with math difficulties. Students with math difficulties. So here are some references for you to read. These are selected. There's lots more research out there on SBI, and I encourage you to pause this right now, find a few of these articles, and to look up even more. I will say that Jitendra is one of the names that always comes up, the third one down. Asha Jitendra, I believe she's at the University of Minnesota, always has lots of information on SBI. So summary, SBI is effective. Its explicit instruction is vital to SBI, and we need to slowly fade support. Do not rip it away. Thank you very much for watching. Please refer to the articles listed on the last slide for more information.